This is experiment 1.5. We know a RS resistor has been added to the circuit. We are going to find the frequency response for different RS values, specifically RS equal to 0 ohm, 330 ohm, and 1 kilo ohm. We're gonna get a frequency response for each resistor value. For the first case, when RS equal to 0 ohm, 0 ohm means no resistance. The result is same as experiment 1.3. In other words, now we are going to find the frequency response for RS equal to 330 ohm. The resistance substitution box has set to be 330 ohm. Now we can begin this experiment. The same as experiment 1.3, we begin with a very small frequency, such as 10 Hz. Reduce the value to 10 Hz. Now it's 0 Hz, no signal in the scope. We need to change it to 10 Hz. There, 10 Hz. So far, we cannot see any signal in the scope. Change the time scale, perhaps we can see something. There, yeah, we do. We can barely see this sine wave. It's very small. If you look at the peak-to-peak value, it's 196 or 200 millivolt. The output peak-to-peak voltage is also 200 millivolt. Record these numbers. Okay, we're gonna increase the frequency again. The next one is 20 Hz. So this is the signal. The input peak-to-peak voltage is 200 millivolt. This value doesn't change throughout the entire experiment. We only change the frequency. At every frequency, find out the output voltage and use it to find out the AC gain. At 20 Hz, the output peak-to-peak voltage is 334 millivolt. Record these numbers. Now we're gonna change the frequency again to 30 Hz. 30 Hz now. So frequency equal to 30 Hz. The output peak-to-peak voltage is 568 millivolt. The data changes, it fluctuates, but that's fine. What we are interested the most is the gain. And then record those numbers, continue changing frequency to 40 Hz. For 40 Hz, the output peak-to-peak voltage is 800 millivolt. Change the time scale so we can see a better waveform. Is 808 millivolt, somewhere around there. Record the numbers and keep changing frequency to 50 Hz. 50 Hz. The input's peak-to-peak voltage is 200 millivolt. The output's peak-to-peak voltage is 110 volt. Continue 60 Hz. For 60 Hz, output is 1.37 volt peak-to-peak voltage. And then keep changing frequency. 70 Hz. (1.62 volt). 1.60 volt. 80 Hz. 1.84 volt. For 90. 2.04 volt. 100 Hz. Peak-to-peak voltage is 2.20 volt. Change here to 200 Hz. For 200 Hz, output is 3.36 volt. $300 output is 3.76 volt. 400 Hz. The output peak-to-peak voltage is 3.88 volt. 500 Hz. The output peak-to-peak voltage is 4 volt. 600 Hz. The output peak-to-peak voltage is 404 volt. 700 Hz. Peak-to-peak voltage is 408 volt. 800 Hz. The output peak-to-peak voltage is 4.40 volt, or 4.80, 4.40 volt. 900 Hz. The output peak-to-peak voltage is 4.92 volt. 1 kHz. The output peak-to-peak voltage is 4.68 volt. And now, let's use 2 kHz. 2 kHz. The output peak-to-peak voltage is 4.80 volt. The input voltage fluctuates. The system is not extremely stable. Make sure to record both input and output values now. We need to use the ratio of these numbers to find the gain. And then the 3 kHz. The input peak-to-peak voltage is 312 millivolt. The output peak-to-peak voltage is 6.16 volt. Write down these numbers and change here to 4 kHz. The input peak-to-peak voltage is 204 millivolt. The output peak-to-peak voltage is 4.48 volt. Write down both numbers. And then change here to 5 kHz. The input peak-to-peak voltage is 208 millivolt. The output peak-to-peak voltage is 4.20 volt. Six kHz. The input peak-to-peak voltage is 228 millivolt. The output peak-to-peak voltage is 4.32 volt. The input peak-to-peak voltage is 200 millivolt, and the output peak-to-peak voltage is 4.20 volt. Take another number. Input's peak-to-peak voltage is 216 millivolt. Output's peak-to-peak is 5.28 volt. Nine kilohertz. Input is 212 millivolt. The output is 6 volt. Ten kilohertz. Input is 204 millivolt. The output is 4.20 volt. Now I'm going to change here to 20 kilohertz. Input's peak-to-peak voltage is 2.24 millivolt, and the output's peak-to-peak voltage is 4.24 volt. Or we can use this number. Input's peak-to-peak voltage is 208 millivolt. Output is 4.24 volt. Now I'm going to change frequency to 30 kilohertz. Take another one. Input is 204 millivolt. Output is 4.20 volt. $40. And then here. So frequency is 40 kilohertz. Input is 200 millivolt. Output is 5.72 volt. $50 kilohertz. Let's get another number. Again, input's peak-to-peak voltage is 208 millivolt, and output's peak-to-peak voltage is 4.36 volt. Input's peak-to-peak voltage is 2.16 millivolt, and the output's peak-to-peak voltage is 4 volt. Input's peak-to-peak voltage is 204 volt, and the output's peak-to-peak voltage is 3.88 volt. That is for 70 kilohertz. Now how about 80 kilohertz? Input's peak-to-peak voltage is 204 millivolt. Output's peak-to-peak voltage is 4.84 volt. $90 kilohertz. Let's get another number. There we go. Input's peak-to-peak voltage is 200 millivolt, and the output's peak-to-peak voltage is 4.44 volt. Now we're going to change here to 100 kilohertz. Input is 208 millivolt. Output is 3.72 volt. Now change here to 200 kilohertz. The input is 200 millivolt. The output is 2.70 volt. Change here to 300 kilohertz. Let it run and then pause. The input is 200 millivolt and the output is 2.06 volt. 400 kilohertz. Input is 200 millivolt. Output is 1.64 volt. .500 kilohertz. Input is 204 millivolt. Output is 1.32 volt. .600 kilohertz. The input is 204 millivolt and the output is 1.20 volt. Let's try again. So for 70 kilohertz, the input is 200 millivolt and the output is 1.04 volt. For 80 kilohertz, the input is 200 millivolt. The output's peak-to-peak voltage is 980 millivolt. For 90 kilohertz, the input's peak-to-peak voltage is 200 millivolt and the output's peak-to-peak voltage is 820 millivolt. The input's peak-to-peak voltage is 200 millivolt. The output's peak-to-peak voltage is 800 millivolt. So I'm going to change it here again. This is 2 megahertz. For 2 megahertz, the input's peak-to-peak voltage is 200 millivolt. The output's peak-to-peak voltage is 416 millivolt. About 3 megahertz. So for 3 megahertz, input is 204 millivolt. Output is 296 millivolt. So for 4 megahertz, input is 204 millivolt, output is 256 millivolt. So frequency equal to 5 megahertz. The input peak-to-peak voltage is 208 millivolt. The output's peak-to-peak voltage is 240 millivolt. Here we have 6 megahertz. Let's try a different number. So for 6 megahertz, the input is 208 millivolt and the output is 192 millivolt. 7 megahertz. Input is 212 millivolt. The output is 200 millivolt. 8 megahertz. Input's peak-to-peak voltage is 216 millivolt. The output's peak-to-peak voltage is 144 millivolt. 9 megahertz. Let's try a different run. Input is 220 millivolt. Output is 142 millivolt. Now we got 10 megahertz. Input's peak-to-peak voltage is 216 millivolt. Output's peak-to-peak voltage is 144 millivolt. This is the end of the experiment.